So we know that 2% of the population, they have the disease. A test is developed to help determine whether or not someone has a disease or not. Remember, one thing is having the disease in reality, and the other thing is some sort of a diagnostic test at the hospital which tells you whether you have the disease or not. Now, if the diagnostic test is correct, then maybe if someone has a disease and the report might show that the person has a disease. In the other hand, the diagnostic test might be incorrect, and we know this happens in reality. So even if a person has the disease, the test might show that the person does not have the disease if it is incorrect. On the other hand, a person might not have the disease and the test might still show the person has disease if the test is again incorrect. So you have to understand, having a disease is one thing, and having a test that shows whether the person has a disease or not. So this is what this sum is all about. And we have information. It says, given that a person has a disease, if you know this information, then the test result is positive is 95%. 0.95 means 95%. So that means if someone has a disease, the probability that the test result will say that the person has a disease, positive test result means positive with the disease, that is 95%. Obviously that means that's good. Given that the person does not have the disease, the test shows positive for 3%. 0.03 means 3%. That's so there is a 3% chance a person who does not have the disease for the diagnostic test to give an error report. So there is a 3% error chance here. So we have to draw a tree diagram. Now remember, I mentioned earlier, in case of tree diagram, the structure is option 1, option 2, and yes, no, yes, no. So option 1 is having the disease in reality. Option 2 is not having the disease in reality. Yes means the test at the hospital shows that the person has disease. No means that the test that the hospital shows that the person does not have disease, even though the person had disease in reality. So let me call the option 1 disease and option 2 not having the disease in reality. So disease is known to be present in 2% of the population. So the chance a person has the disease is 2%. That means 0.02. So the rule of probability is, if one of the probability is something, if you want to find the opposite of that, you do 1 minus that. So 2% is 0.02. So the probability of not having the disease is 1 minus 2%, means 98%. So this would be 0.98. 1 minus 0.02. So now we have the other two options: yes, no, yes, no. So positive, negative. Positive test result, negative test results. Okay, first of all, given that the person has the disease, so going through this branch, in reality the person has disease, so the test is positive is 0.95 or 95%. So this branch would be 0.95. So automatically this would be 1 minus, because it's the opposite. 1 minus 0.95 is 0.05. Again, given that the person does not have the disease, this is this branch, the test is positive, so the positive test is still 0.03. So this would be negative, would be 1 minus 0.03, which means 97% or 0.97. So we are set with the tree diagram. Now the next question. So next question says, find the probability that the test is positive. We have to select a person. So how many ways can the test be positive? Test can be positive in one way, is the person has the disease and the test is positive. So it could be DP, or it could be the person does not have the disease in reality, but the test still shows that the person is positive test. So D prime P. So it would be D and P is 0.02 into 0.95, or D prime is 0.98 into 0.03, 0.0484. A doctor randomly selects a person from the population and tests for the disease, given that the test is positive. In question number C, it is given that the person has positive test results, so positive. So this is given, so positive. Now what we have to find the probability that he does not have the disease in reality. So does not have the disease means D prime. So this would be equals to So positive, so we just found this out in the previous sum. So probability of being positive with the disease is 0.0484, and we need here that he does not have the disease in reality. That means A intersection B, so that would be D prime into P. 0.6074 means 60.7%. so that means given that the test result is positive, the probability that he does not have the disease is 60%. That's a very high probability of a person where that hospital diagnostic report is saying he has the disease, but in reality he does not have the disease. That's a 60% chance. So that means the diagnostic reports are not very good. Anyway, let's do the next question. So the next question is, comment on the usefulness of this test. So the test is not very useful. The test is not very useful since a person who does not have the disease has a high probability chance of a positive test result from the hospital. Positive test. So this question number D, it's not a question from a technical question or something. It is something, what do you think? You have to use your common sense. So there are many paper where we have 1 or 2 marks regarding this. You don't have to spend too much time solving this type of question. Just read the question and write it intuitively.